Okay, so my idea was clear that today I'll start with a little bit of basics of everything. In 1 or 2 days, I'll try to cover trigonometry and all these kind of things. Okay, so some classes, like although it is we have a plan to start from vectors, but I want to deal with that slope method and all those kind of things. Got it or not? So where we get stuck, the slope and all those terms when it starts to appear. Yes. Okay, so the first word which we are going to talk about is the angle of triangle, which we also call it as trigonometry approach. Yes or no? Now, when I look over here, try to see. So let's suppose if I have a triangle, a right angle triangle, then if this is angle theta, opposite side is perpendicular, this is base and this is hypotenuse. We write sine theta as perpendicular by hypotenuse and cos theta as base by hypotenuse. Correct? Yes or no? And tan theta as perpendicular by base. Are you able to get me? Now all of these are just simple approaches. Now if I consider, let's suppose if I just consider these only triangle, but with the approach of one big angles like 37 degree, then opposite of 37 is always 3 and this is considered as 4 and this is considered as 5. So each angle I can derive it or not. Like if I write sine 37, so it is what? Perpendicular by hypotenuse. So it is 3 by 5. Opposite of 37 is always considered as 53. Are you able to get me or not? Okay. Now remember the idea is clear. Opposite of theta is perpendicular. Are you able to get me or not? So if 53, if I'm considering opposite of 53 is what? 4 over here. Are you able to get me? So if I write if I let me complete first 37. So cos 37 if I write, it is base by hypotenuse. So it is 4 by 5. Okay. And if I write tan 37, 3 by 5. What is tan theta? Perpendicular by base. So it is 3 by 4. So these, basically, tan theta is what? Perpendicular by base or not? So if this is 37, this is perpendicular and this is base. So always it is going to be constant value 3 by 4 only. Got it? It is always constant. It is always constant. It will never ever change. Okay. Yeah. So remember that these are irreplaceable. Basically, it is a trick which has been created such as to do the things in a better way. Okay. Now, if these are satisfied, you can write for cos sine 53 also. Like I'll write for sine 53. Sine 53 will be once again perpendicular, which is 4 by 5. And if I write cos 53, that is equal to base by hypotenuse, that is 3 by 5. Are you able to get me? Now, you have to remember, let us think of a circle. Okay. If this is my circle, my voice is clear now. No background is there now. Okay. That's fine. So, like let's suppose if I have this as a circle, then you know that let's suppose if a particle travels from these 2 points, like this is point A and it travels till point B in this circular arc. Okay. So then the length of this arc, if I say this length AB, what it is called as? Arc length. It is called as what? Yeah. And this arc length has formula. If the circle has radius r and it has a center O, then this AB length, which is a arc, it has a value of r into theta, where theta is the angle subtended by arc at the center. Okay. So each chapter, do you have printer in your home? Yes. So after every topic, I'll give you one DPP, got it or not? Okay. And that you will have to solve within 15 minutes and share me the answer key, and then I'll share you the correct answer key, and you will say how many are correct and how many are not correct. Okay. Every day you have to go like that. Means if I complete the class, as soon as you will not leave, you will solve that DPP for 15 minutes. Okay. That's your idea. Got it? Now, let us move on to this. So, this is our idea of arc length, which is given as r into theta. Now, question arises that in between this AB, I can travel directly straight from A to B or not. Then if it is theta, this is radius r, this is also radius r, then what is this AB length? If I talk about this AB, means this particular straight line. Think about it, what it can be. Can I draw one perpendicular from center O to AB? So basically, if this is whole is theta, so this angle will be how much? Theta by 2 or not? Confirm? And this is radius r. So DB works like a perpendicular for triangle BOD or not? Think. In triangle BOD, BOD is like this way or not? This is B, this is D, this is O, this is radius r, and this is theta by 2. So BD is what? A perpendicular of theta by 2 or not? Tell me yes or no? Yes? If it is perpendicular, perpendicular can be written as hypotenuse into sine theta. Yes, so BD can be written as hypotenuse is R, so R sine theta by 2 or not? Tell me yes or no. Is this correct? Now, if I find AB, then AB is twice of BD or not? AB from here to here is straight line, not the R. Okay, so it is twice of BD. If it is twice of BD, it will be written as what? 2R sine theta by 2. Do not cancel this 2 and 2. This sine theta by 2 is itself a number. Got it or not? Think like trigonometry as a number. Are you able to get me? Is that clear? Why? 2r sine theta by 2. Okay, now look over here. See, basically what is BD? R sine theta by 2 or not? So 2r sine theta by 2. Simple. Is that clear? No, never. Why? Because sine theta by 2 does not means theta by 2. Sine theta by 2 is itself whole as a number, and that's why we call it as a function. Got it or not? Okay. So basically, here this 2 is dividing my theta inside the sine. So how come, like, basically, if I want to beat someone, let's suppose I went to fight, and there is one guy who is in his home, so I can't go inside and beat him now. So that's what is like that. So this 2 can't go inside and cut that 2. Okay. Is that clear? Okay. So now this was the idea of triangle. Arc length is given as r into theta, and then this AB is given as 2r sine theta by 2. Are you able to get me? Okay. Now next point, the idea is very simple, that when we consider this arc length, everything and all, now let us take once again a circle. Okay. So if the radius of the circle is r and the angle subtended at the center is theta. Okay. Now think of one case, if this circle, if this whole circle is rotated in a full one revolution, so angle subtended at the center will be how much? Imagine like this way, like let's suppose if this is a straight line and I started with another straight line like over here. So if I rotate it like this way, then how much I am subtending? 360. So in one revolution, how much angles I am subtending? 360, yes or no? So look over here. Let's suppose if a particle travels for this whole angle, theta is equal to how much? 360 degree. Yes. So therefore, our formula arc length, which we write over here, arc length is arc theta or not? So arc length will be radius into how much? 360 degree. And in one revolution, we complete one circumference of the circle, yes or no, which is 2 pi r or not? Yes or no? So that means that this 2 pi r must be equal to arc length or not? Yes, because arc length is nothing but the length across the circle. So that must be in one revolution must be equal to 2 pi r. Yes. Can you understand my point? So this is why we write r got cancelled and pi means how much degrees? 180 degree. What does the pi value means in mathematics or physics? It means that it is equal to exact how much angles? 180 degree. Are you able to get me or not? Is it clear? Yeah. Yeah. Finally, point that means that 2 pi is equal to how much? 360 degrees. Is it clear? Okay. So now let us move on to next point. So first we got the idea of angle. Now my idea is simple that someone see pi is what? Pi came out from 2 pi r or not? And 180 came from 360 degrees. So what is this pi? Pi is nothing but the unit of length or not? Yes. But this is what? Degrees or not? Yes. So I should know how to convert length into degrees. So this length pi is also known by a name called as radian. What it is called as? Radian. Are you able to get me? Yes. So basically I should know now how to convert radians into degrees. Radians means writing the answer in terms of pi. Degrees means writing the numbers in terms of degrees. Are you able to get me or not? So that conversion. So let's suppose if I want to convert, let's suppose I want to find r radians. So let's suppose there are some x radians is given, okay, and you want to convert it into number of degrees. We will multiply with, so therefore the number of degrees, therefore blank degrees is equal to how much? I want to convert into degrees or not? Yes, you told correct, simple, sir. Radians is given. Ultimately, I should cancel the radian. So I should divide by pi or not. So x divided by pi multiplied by 180. This will convert into degrees or not. See the right hand side. It is in degrees already. Because pi, because already radians is given. So radian will cancel and I'll get the degrees. Yes or no? Yes. So if I convert some, you can say x degrees into radians. Yeah. So idea is simple. So therefore, number of radians, blank radians I'm writing is equal to whatever is given degree. X is given degree now. So x degree and multiplied by pi by 180. Degree should cancel. Yes or no? Now, another trick is this trigonometry was based on the hour hand clock. Yes or no? Trigonometry is based on hour hand clock. Now remember that 1 hour of a, or you can say 1 degree of in this whole segment represents 1 hour. Are you able to get me or not? So that means 1 degree will be represented as 60 minutes or not. So if I use this sign, single dash, that means I am writing in terms of minutes. In what I am writing? Minutes. Yes or no? Then this 1 degree is also equal to 3600 double dash seconds in 1 hour or not. So double dash means seconds. Are you able to get me or not? So this is the idea of considering different kinds of angle in terms of hours. 1 degree is equal to 1 hour, 1 degree is equal to 60 minutes, and 1 degree is also equal to 3600 seconds. Is that clear or not? Is it totally clear? Now let us establish the trick of understanding how to write the quadratic, basically trigonometric values in a very easy fashion. See, this is x, this is y, this is minus x, and this is minus y. So we have two calculations, either x-axis calculation or y-axis calculation. Yes or no? Let me make it small. Sorry, let it be as it is. We'll reduce its size. So can you see this? Yeah. Now look over here. Let's suppose if I draw a right angle triangle over here, okay, and if this is the angle theta, so here all sine theta, cos theta, everything can be defined or not in easy way. Yes. But see, the same triangle which I have considered will give also the same results if I just draw a rectangle in top of it. Yes. But for that, the angle of consideration will change or not. This angle I have to consider, what is that? 90 minus. So how many calculations lies in the first quadrant for which you will get the same perpendicular as a base and this perpendicular as a base of this triangle? Yes or no? So we have such two angles or not, theta and 90 minus theta. Are yes? Did you understood what I said? See, simple. If this is total angle is what? If they are perpendicular, then it is 90 or not. So if this is theta, then this will be how much? 90 minus theta. Yes or no? So if this is working like a perpendicular for this triangle, okay, this will work like a base for this triangle or not for 90 minus theta. Yes. So whatever I was getting as sine, I'll get as cos over here or not. So this is why calculation changes when you write 90 minus theta, 90 plus theta and all. And this is why we have the root. So in this is called as first quadrant. What is called as? This is second, third, and this is called as fourth. Is it clear till now? 1 minute. Yeah. Now, when I write first quadrant, so in first quadrant, what are those angles? Either I can measure in terms of theta or I can do the measurement in 90 minus theta. Yes or no? Then if I go in this total angle will increase or not? Either it will be 90 plus theta or 180 minus theta. Yes or no? Correct now. Because see, this is 0 degree. This is now y axis is 90. This is 180. This is 270. And this is once again 360. Yes or no? So 0 plus theta is theta, but another angle will be 90 minus theta or not. So here second angle will be what? 90 plus theta. Y axis is 90. But if I measure from this side, it will be 180 minus total angle is 180. So this angle will be 180 minus theta or not? Yes. Tell me what will be the angles in third quadrant? Very good. 180 plus theta, 270 minus theta. Here, very good. So now you got the idea. Yes. So this is second quadrant. Now the idea is simple. All trigonometric ratios are positive in first quadrant, while sine and cosec are positive in second quadrant, while tan and cot are positive in third quadrant, and cos and sec are only positive in which quadrant? Fourth quadrant. Are you able to get me? This is called as division. Now I'll leave this over here. This is the mathematics form. I'll just leave it over here and then I say get lost, because this thing does not help us too much because it is too hard to remember. Yes. Then I remember one trick. I remember one x-axis calculation. And then I remember y-axis calculation. So I follow how many two rules of calculation? Two rules. X-axis, y-axis. The idea is simple. See, by looking at this quadrant, you can see that from x-axis we measure angle theta. Then we measure 180 minus theta and 180 plus theta or not. Tell me yes or no. And then I measure one more angle 360 minus theta also or not. 360 plus theta I'm not going to consider. Yes. So see, we can see that, sir, from x-axis we have four angles. One is theta, 180 plus minus theta, and then 360 minus theta. Can you tell me what are such y-axes is? Yes, 90 plus theta, then means 270 plus minus theta. Yes or no? Now, the idea is clear. If these are my such calculations, then if it is a x-axis calculation, we will see that the sign, this trigonometry is never ever changes. It remains as it is. Means sine remains sine, cos remains cos, tan remains tan, cot remains cot, sec remains sec, and cosec remains cosec. Are you able to get me or not? Now, if they are same, that means that we can write this as, therefore, we'll write for y-axis. You can see the rules are different. We know that whatever was perpendicular over here is working like a base over here. So this is why we write sine changes to cos for y-axis, cos changes to sine for y-axis, then tan changes to cot for y-axis, cot changes to tan, and sec changes to cosec, while cosec changes to sec. Are you able to get me or not? So can you understand this, that you do not have to think about anything, just you have to remember if anything is written, whether it is x-axis calculation or y-axis calculation, and in which quadrant it is. That's all. That's your answer. So like, let's suppose I wrote something like, in exam it says that uh, someone wrote sine 270 plus theta. Then you have to identify how to write this answer. Is this is a y-axis or x-axis calculation? Is it x-axis? 270 is y-axis. Yes or no? 90 multiples are on y-axis. Got it or not? Okay. So then this is what sine will, for y-axis what will happen? Sine will change to, simple. The answer is cos theta. Now then still the process is not over. First you will follow the interchange. Then you will see that in which quadrant this 270 plus theta lies. In which quadrant it is? Fourth quadrant. Does here sign remains positive? No. So sign changes as negative, because this quadrant rule is applied on left hand side on. Where it is applied? Okay. So tomorrow onwards, you should make a perfect notes. Okay. I'll give you the time to make the notes. In that only you'll have to make. Now, tell me, what will be the answer of similarly? Tan 180 plus theta. Which axis it is, x or y? So I'll get exactly tan theta. Then it is in which quadrant? And in third quadrant, tan remains positive. So what is there? Nothing. Isn't it this is easy? So let's take an example. Tan, sorry, let us write cos 120 degree. What I will write? Easier are x-axis or not? Because in x-axis, no need of interchange. Yes or no? Can I write 180 minus 120, 180 minus 60 or not? Basically, I have to represent this in terms of such a way that it should be either in 180 or 90. Yes. So 270 minus how much you will write? You will have to write a big number or not? Yes. So this is, it is easier not to write in, I have to see, ultimately we know the answers of sine 0 to 90 degree of any trigonometric ratios, yes or no? So our idea is very very simple, that anyhow we'll try to convert these angles in form of that. Okay, is that clear? 1 minute, I'll just close the door. I don't know, I've opened the tank. The locality where I'm currently right now, the persons are very dangerous over here. I don't know what they do. Okay, can we move ahead? Okay, so are you alive? Not dead yet? So cos 180 minus theta. Once again, you see, is it x axis or y axis calculation? Uh-huh, x axis. So this will be exactly cos 60 or not? Directly, na? Whatever is this theta will appear. Here it is theta 60 degree or not. So it will, then it is in which quadrant? First or second? Second. So cos is negative over there or not? So minus cos 60. Cos 60 is 1 by 2. Yes or no? So answer is minus 1 by 2. Is it easy peasy or not? Yes? You tell me. Uh-huh. Cos, let's suppose, what I should get? 210 degrees. Now you tell me fast. Within less than 1 minute. Correct. Mm-hmm. 270 minus 60, third quadrant. Yes or no? So minus sin 60. Correct. Minus root 3 by 2. Easy peasy. Yes or no? So this is the idea. You have to follow which axis rule? Sin x axis and y axis rule. Okay. And then quadrant. Step is what? What are our steps? Step 1. See the x or y axis interchange. Yes. And then step 2 is see the left hand side equation in which quadrant it lies. Got it? So this is the idea. This is the idea to do the trigonometry. Are you able to get me or not? Okay. So now some important formulas, and this some important formula you should keep it as a snap notes. Okay. Always revise it. Basically, it's like if I write sine 2 theta, it is 2 sine theta into cos theta. Are you able to get me or not? Second one is sine square theta plus cos square theta is always equal to 1. Third is 1 plus sec square theta is always equal to tan square theta. Fourth one is, if I write 1 minus cos theta, it is nothing but 2 sine square theta by 2. Are you able to get me? If I write 1 plus cos theta, 2 cos square theta by 2, 1 minus cos 2 theta, 2 sine square theta, and 1 plus cos 2 theta, 2 cos square theta. So this is the formula of, you can say, half angles. Are you able to get me or not? Okay. If I write simply sine theta can also be written as 2 sine theta by 2 into cos theta by 2. Okay. How? This is a very big derivation. Okay. Okay. So we are not deriving it. We are just learning it right now. Okay. So that is called as half angle approach. That sine theta can also be written as 2 sine theta into cos theta. Are you able to get me or not? Then cos A plus minus B, it is written as cos A cos B, and then sign changes, opposite, it inverts, minus plus. If it is plus, then I'll get minus. If it is minus, then I'll get plus. Sin A sin B. Are you able to get me or not? Then sin A plus B, it is same, sin A cos B plus minus cos A sin B. So these are the basic formulas which you should always keep in your mind, such as to solve any problem of physics. Are you able to get me or not? These are the basic requirements, you can say. Is that clear? So these are some of the ideas with which we'll have to always move ahead, such as to do any kind of problem. Okay. Now the next idea is called as the word slope. Okay. But before that, I have to make you understand perfectly differentiation. Okay, let me stop this recording.